Hi and welcome. Good morning. Well, actually, good afternoon to you and good morning to me. And I was almost late because time zones. So it's currently 9:44 today at my place in Berlin, in rainy Berlin, Germany. So it's a chilly 12 degrees outside Celsius. So yeah, pretty fun. And welcome to my talk on the topic of infrastructure is code on AWS. So we're going to be looking at some infrastructure as code frameworks on AWS, some tools, some best practices, and something that can, make your life that much easier, right? So without further ado, let's move into my clicker doesn't work. Does it work now? Does it work now? It doesn't work. I always have a keyboard. Yes. Let's look at the agenda for today. I'm going to cover a bunch of things, and I promise I'll do a demo as well. So it's not just going to be me, not just going to be me showing it slides. So, but this agenda is very boring. Let's move on. So let's talk about what is infrastructure as code. It's the year 2020. Everybody is running in the cloud. Everything is containers. Everything is serverless. Not a lot of things are standard EC2 instances, although they are, not so much. We need to find a way to make all of that quite manageable, right? And how do you manage things at scale? How do you set up 1,000 containers? Like, how do you set up 500 clusters for containers? You can click, absolutely. But that's not the best way to do it. So you do things through code. To be possible to do it at scale, to do it safe, to do it repeatable, you do things through code. Now, let's take a step back and see how this used to be. A long time ago, well, actually like 7 years ago, I used to work for a company that I used to be a thing called a server provisioning administrator. And my job was basically, hey, Darko, can you go and install operating systems on a bunch of servers? And it was a big company, and we had a massive global footprint. Well, not global, American footprint. And my job was basically, hey, I have 500 physical servers for you in Fairbanks, Alaska. Please take your favorite Java-based remote management utility and mount your ISOs and install the operating system manually. And, I got 500 servers, and it took me, it took me maybe like 3 to 4 months to set all that up. No automation, no scripting, no tooling, nothing. It's basically every server by itself. So it took a long time, right? So imagine in 2020, in your current job, that somebody gives you 4 months to set up a single environment, a single piece of workload or infrastructure or something like that. So that doesn't work, right? So infrastructure like this, of course, it does exist. But when you think about infrastructure today in the cloud, it's more like this, right? It's more like some piece of code, right? It's text. It's no matter what you do on the cloud, no matter if you're running EC2 instances, if you're running serverless, if you're running containers, everything you do is done through code, even though you're clicking on something, right? So every time you click on the AWS console, you're making an API call to something, and that API call is creating resources. Now, why should we do that? Or in essence, what is the definition of infrastructure as code? Well, infrastructure as code is the process of defining your infrastructure through, well, code, right? You create these things called templates, and in those templates, you describe your resources and how do they look like, or how are they configured, and then you let some other black magic framework thing do the job for you. So it's great because it makes your infrastructure changes predictable and repeatable, right? Doing 500 servers at once is difficult, but doing them twice is twice as difficult. But it also gives you the ability to actually release changes to your infrastructure with the same tooling that you do for your application changes, right? And on top of that, replicating production environments to staging and development is much, much easier, right? So the goal of infrastructure as code is basically to treat your infrastructure code as any other application code, right? So, but before I go into it, there's 2 types of infrastructure as code, or actually 2 approaches, because a lot of people tell me like, so Darko, that this is nothing new. I scripted my way through life. I've done infrastructure as code since 1996. Well, there's two types of infrastructure as code. There's the imperative one, where I say, I tell you what to do. This is for all of us script buddies who drops their presenters. This is all, basically I write the script. This script uses Python or Bash or Batch or whatever. And I tell my cloud vendor or whatever, launch me an instance or create me an S3 bucket. And this is imperative. I tell it what to do. I tell it exactly what to do. And if I repeat it, it's going to do it again, which is okay, but it's not the best. The better approach is to using declarative approaches to infrastructure as code. And that is, I tell you what I need. I describe, hey, I need an instance. And this instance needs to be configured in such a way. I don't care how you're going to do it. I don't really care what framework you're going to use. I don't care what API call you're going to make. Just give me an EC2 instance that's configured in this way. And this, in my opinion, is the better approach to things. So before we continue, you might be wondering, who is this bald person and why is he screaming at the camera early in the morning or late afternoon to you? I got a great intro by Michelle, but my name is Darko Meszaros. I'm a developer advocate based out of Berlin, Germany. I'm originally from Serbia. And the fun thing about me is, like, I've changed 5 countries in the last 7 years. So from Serbia to Czech Republic to Malta to Ireland, and now living in Germany. So I'm kind of sick of traveling already. As mentioned, I've been working with Amazon with almost 5 years. Yeah, 5 years now at Amazon. Started in premium support, moved on to solution architecture, and now I'm a developer advocate. And my job is to talk to you, our developers, our engineers, the folks who build things on AWS, and get your feedback on the way we do things, and try to educate you at some other things, and also entertain at certain points. By the way, if you want more of this, or more of me talking at you or screaming at the camera, do check out my social media, especially Twitch and YouTube, because I do a lot of additional content such as streaming and videos as well. So make sure to follow me there. All right, let's start with AWS CloudFormation. This is the big boy in the room, right? So this is the OG infrastructure as code framework for AWS. Now, CloudFormation is the infrastructure as code on AWS. It's the original one. It's the one I first saw in my life. It used to be very bad, and I'll get to that in a moment. Now it's okay. It's not the most comfortable thing to work in, but it is very flexible. So CloudFormation is basically a way that you can take. It's a common language. I use language in quotes because it uses YAML and JSON, and those are, yes, languages, but not a programming language per se. It gives you the ability to create things called templates. And templates, as you can see here, this is a YAML option, a YAML format of it. Templates contain these things called resources. And in those resources, you configure properties of those resources. And once you deploy that template, you create a stack. And in that stack, you have those actual resources being created. Now, you can create over 490 resource types on AWS, but that's actually even more right now, because I'm not sure if I'm going to mention it today, but I might as well. There's a thing called CloudFormation Registry, and that's just a feature that enables you to basically create your own custom resources in any way you want it. So pretty cool, pretty flexible. It goes down to the weeds, and people were saying this. If you would think about the levels of languages in the world, compared to the level of languages in infrastructure as code, CloudFormation would be the assembly language, because you can do all the nitty-gritty things with it. So, so pretty useful. And that template, I mean, you've seen an example here, but you can do a bunch of things on the template. It's not just defining my resources. You can also do some conditionals. You can do parameters. You can create mappings. Basically, create a small map of using specific values depending on certain things. You can set up outputs. Basically, you can make your template be very agnostic. So by passing in parameters or maps, you can reuse your template for multiple different things. For example, if you ever wanted to create a staging environment out of a production environment, well, you can do that with the power of parameters. And as any good code out there, it can also sit in a pipeline, and it should sit in a pipeline. So you have the ability to stick CloudFormation templates and test them through a proper pipeline setup with all the bells and whistles such as linting and unit testing and even integration testing as we later go on. So pretty cool. There's a whole bunch of tools on it, and I've been talking about the tools for CloudFormation testing in some of my other talks, the deep dive on infrastructure as code, but there's a bunch of them that can actually help you quite a lot when it comes to CloudFormation. But yeah, you may use resources outside of AWS. And this is my chance to talk about the CloudFormation Registry. Now, the CloudFormation Registry is an open approach to managing resources on AWS. In essence, it gives you the ability to create these things called custom resources. Now, if you have used CloudFormation up until now, you may be screaming at your screen saying, hey, custom resources already exist, buddy. I use my Lambda functions for them. Exactly. This is a different approach. It doesn't require you to tape up a bunch of Lambda functions, and some string and rope. It actually gives you the ability to write the entire logic for your custom resource to CloudFormation, and in essence gives you the ability to launch the custom resource directly from your CloudFormation template, like you would launch any other resource without having the need to create complicated Lambda functions to do these things. Now, why are these things important? Well, especially when we talk about our third-party partners and integrators that like companies like Datadog and Spotinst, they already have code and everything enabled for their own resources. So, for example, if you're using OpsGenie and you want to create a user, and oh, my coffee is here. If you want to create a user, and thank you, Paula. And you want to create a coffee, sorry, just give me a second. We can continue. Okay, if you want to create a user in OpsGenie or something like that, it gives you the ability to do that straight through CloudFormation, which is amazing. And in essence, this feature gives you the ability to launch resources anywhere, even outside of AWS, which is pretty cool. So let's talk about CloudFormation's younger little brother, SAM, or the serverless application model. So who is SAM? SAM is basically a transformation on top of CloudFormation. It basically gives you the ability to do anything that CloudFormation can do. But on top of that, you can also work with serverless applications that much easier. So in essence, it looks very similar to CloudFormation, but it has specifically formed the resources for serverless application. What does that actually mean? So here's an example code. This piece of code in just 20 lines of code creates a Lambda function, an IAM role, and an API gateway. And also in the bottom, you will see it creates a serverless, a DynamoDB table actually. So you can do all of these things directly through CloudFormation, absolutely, but it's that much easier to do it in SAM. So if you're writing a serverless application on AWS and you're thinking, should I use CloudFormation? You should use SAM. So it's much easier to do it with SAM than it is to do it with CloudFormation, because it takes much more code to do the same thing on CloudFormation as well. But that's not all. SAM in itself has, like any good tool worth its salt, it has a CLI. So there's a small CLI utility that gives you the ability to build, test, and actually deploy your SAM applications. What's great thing about it, and the question always comes up, hey, serverless applications are fine, but it's very difficult to develop serverless applications anywhere. Well, with SAM, you can kind of bridge that gap a bit, because SAM enables you to do like local development and local testing of your serverless applications, as it can emulate Lambda functions and API gateways, for example. So the SAM CLI is pretty cool. It's an open source tool that you can install using pip or brew or your favorite package manager of choice. You can initialize an application by basically building up the entire scaffolding and structure of a directory for your serverless application. And then the lovely SAM local stuff, basically the ability to actually test the Lambda function locally. And you have a bunch of other features such as validating, building, packaging, these things that actually make sure that your code works, and deploying it as well. And these things in this little square actually are fine, but they do not belong on your workstation. They belong in a pipeline, right? So with the Jenkins SAM CLI plugin or with the code pipeline integration for CloudFormation, you can actually stick these things into a lovely into a lovely pipeline that enables you to deploy this thing through a proper CI/CD process. On top of that, there's a few other features such as giving you the ability to stream logs from your serverless function directly to your workstation. So if you want to, in real time, look at some logs of your Lambda function inside of your terminal, which is amazing for debugging, you can do that. And for all the serverless application repository fans, you can also publish your application to SAR. Okay, did I mention local tests? Yeah, yes, I did. I talked about local tests on SAM and how can you do this thing locally. And luckily, I have a pre-recorded thing that I can show you. So here's an example of me creating I have a super simple serverless application consisting of one Lambda function. Nothing special, Lambda function written in Node.js, just works, right? Apparently. But I also have like this is my Lambda function, just saying hello and then giving out the name. Nothing else, just depending on which name you pass it, it says hello that. Okay, cool. So how do I test this locally? Well, I created an event, and an event is basically something that passes on the value. So I'm just passing a single event called name, and I can invoke SAM local invoke, pass the event, and then just specify the name of the handler. So it's basically invoking that. It's pulling up a container image, and you can see in the bottom it says hello alarm forth. So that's it. So it was able to successfully emulate a Lambda function run on my workstation in a very, very short amount of time. The only thing that you may have a requirement for this is you need to have Docker installed, and you need to run it at least once so you will have the latest Docker image for Lambda. You know, if you decide to do this on an airplane with no internet at one point, you might struggle initially. Okay, so now let's talk about, would this be the younger brother or the uncle? I would call it more the uncle of CloudFormation, or a cousin or something like that. But yeah, it's the favorite thing of a lot of people right now, and it's the Cloud Development Kit, or CDK. This is another framework. Now you may be asking yourself, Darko, you already showed us two frameworks. Why CDK? Why another three-letter acronym? Well, you may hate JSON or dislike JSON like I do. Maybe JSON is not for people. JSON is a great thing, but not for reading. Or maybe YAML ain't your thing, right? You don't like tab spacing and you struggle with all those things. But most importantly, maybe you are just an amazing person when it comes to Python or some other language, and you have all the knowledge and the capabilities of writing your applications in Python or Java or some other language. And why not use that? Why not use the capabilities of those languages to write your infrastructure? Why do I need to struggle with YAML and JSON when I already know a proper programming language? Well, exactly. So with that, AWS CDK actually gives you the ability to use your existing knowledge and toolchain to develop infrastructure as code applications. Hence, you can use things like Java, JavaScript, TypeScript, Python, C#, and F# as well. I have a little icon here, but also Golang is coming up in late 2020. So without the need of having to reinvent your knowledge in infrastructure development, you can use your existing toolchain and language skills to do that. And infrastructure now looks like any other piece of application code, because here's a great example of, I think this is TypeScript. Yes, TypeScript. By basically using the same language preferences, the same syntax, and even the same capabilities of a programming language, you're able to deploy proper infrastructure, right? So, and how does this look in reality, or what does it actually consist of? Or let's take a peek behind the hood a bit. So, in essence, you write your code in these thing called apps, right? Or you create an application, and this application contains stacks, like any good infrastructure as code service, and those stacks contain resources, right? So this is where you write your JSON, your JavaScript code, or TypeScript, or Python, whatever. This is where you write your thing, the meat and potatoes of stuff. Then there's a CLI. because of course there is a CLI, and the CLI actually takes your code, takes the things you have written, converts it to CloudFormation. What? Yeah, it converts it to CloudFormation, and then lets CloudFormation do the rest. And this is very important because there was no need to set up CDK to handle the creation of resources on AWS or maintaining those resources on AWS, because there's already a very good service that does that, and it's CloudFormation. So with CDK, we have basically ripped out the complexity of writing YAML and JSON and converted it to using proper programming languages, and just have a little tool that converts it to CloudFormation, and actually it deploys it. So you don't have to convert it and then do manual deploys. You can actually do it straight from the command line. It's amazing. But that's not all, right? It's not just, this is not just a translator from JavaScript to YAML. No, there's a bunch of other things that are important when it comes to CDK, and those things are called constructs, or the way you define, the way you build your resources and stacks. There's 3 types of constructs on CDK, and this is very important for people to know, because this will make a choice which ones you will choose, right? You can mix and match, by the way, but the default CloudFormation constructs, and this is where the beauty of it comes in. Anything that CloudFormation can do, you can do it with CDK, because there's a CloudFormation constructs which basically takes the same syntax or the same parameter sets that CloudFormation can take and create resources from that. So if you want to create a single VPC, you can create just a blank VPC using a CloudFormation construct from CDK. If you want to take it a step further, or use something called the service construct, and this is what most people use. This is a higher level abstraction with sensible defaults, right? So if you create the VPC through a service construct, it will not just create a VPC, it will create a VPC, 4 subnets, 2 public, 2 private. It will create 2 NAT gateways. It will create all the internet gateways and all the route tables, all the things you need to actually successfully run a VPC. And finally, while I take my cup of coffee, the design patterns. And the design patterns are, have a look at that code. The design patterns are another layer of abstractions on top of service constructs. It gives you the ability to actually have opinionated reference architectures being deployed through 5 lines of code. So in these 5 lines of code, we actually deploy 817 lines of CloudFormation. It actually creates a fully load balanced, application load balanced Fargate service. So it creates a whole cluster of container services in the backend with all these features and things from the 5 lines of stuff. So pretty cool, pretty important, right? It gives you the ability to kind of create very complex things in a very simple way. But at the same time, you can also tweak it a bit. You can set up some specific properties. And because these design patterns are kind of like a community thing, and everything here is open source, people keep on contributing to design patterns, and you have more and more design patterns out there to use inside of your applications. And because this is a generic programming language, again, depending on which language you use, you have the ability to actually run tests. So you can actually test your code before you deploy it in a much better way. CloudFormation had the ability to do things like syntax checking and linting, or you can actually deploy it and see if it deploys successfully. But CDK can actually do things such as snapshot tests. It can do fine-grained assertions and validation tests. So for example, if you're using if you are using something like JavaScript or TypeScript for AWS or for CDK, you can use the Jest framework to do like the testing of your CDK code. So you can define, hey, I expect that my template contains, I don't know, an SQSQ with these following settings, and if that is not achieved initially, it will fail. So those kind of things. But you know what? Let me actually. This is a bit out of left field. Let me try to show you something. I believe you can see my terminal right now. Michelle, can you just confirm that? Yeah, perfect. Thank you.
Affirmative.
So yeah, thank you. I'm gonna go and create a simple CDK application. Again, I'm looking up because my screen is up. Okay, mkdir CDK demo. Let's go to CDK demo and let's CDK init language TypeScript. So I'm basically doing the following. So I'm telling CDK, initialize my application, create the entire folder structure for my application by using the language TypeScript. So I've opted in to write my infrastructure in TypeScript in this case. And if I do this, like so, it will do npm install all the wonderful things around npm. It will install all the packages. It will install all the things I need for my application. And yeah, let's do this. I'm going to create a super simple thing, but something that's very complex to do in CloudFormation. So if anybody here has ever used CloudFormation to create a VPC, a virtual private cloud on AWS, you'll know what I'm talking about. So let's have a look. So here, I have a directory structure. I have a bin file. This is where my application starts. And I have my lib file. The lib file is basically my construct. This is where the meat and potatoes, where my code goes. And that's what I'm going to be editing. So if I open up my lib, and there's this CDK demo stack. So this is where I define my entire stack. I want to create a VPC, right? And to create a VPC, I need to actually import a module that will allow me to create a VPC. And the module for VPCs is actually the EC2 module. So the same as before, same as line 1, I can just copy this one, call it EC2, and then import it from AWS EC2. Now, it's going to complain because I don't have that module installed. So to install this module, I can do npm install at AWS CDK, AWS EC2, like that. I think this should be the one. Now it's installing the module just locally. And once this is finished, yeah, that's fine. Once this is finished, I should have it here. Perfect. Now, to create a VPC, to kind of set the scene for those ones who have not created a VPC on CloudFormation before, I think it takes like 92 lines of code to create a CloudFormation template. To create a CloudFormation template, to create a fully functioning CloudFormation, a VPC in CloudFormation, you need to create a VPC. You need to create subnet 1, subnet 2, subnet 3, subnet 4. You need to create internet gateways. You need to create a route table. You need to create a route. You need to create route subnet association for subnet 1, subnet 2, subnet 3, subnet 4. If some of those, if 2 of those subnets are private, you need to create net gateway 1, net gateway 2. You need to change the routes for subnet 1 and subnet 2 because they're private. And then it works. Yes. So like 90 some lines of code. Again, you have very fine grained control of what you're going to do that. But if you want to do the same thing in CDK, you can do const VPC. Actually, let's do it properly. My VPC equals new ec2.vpc, the construct, and call it my VPC. Well, bam, I've created a VPC, right? I've created a VPC live on YouTube with just a single line of code. And if I save this, let's exit out npm run build, and it will now compile my TypeScript to JavaScript. And if I do CDK deploy, this will actually deploy my CDK stack to AWS. It's basically creating CloudFormation stack set, or actually a change set, and it's going to be deploying it hopefully into my CloudFormation setup in a moment or so. So it creates a VPC, an internet gateway, elastic IP addresses. Oh yes, I forgot elastic IP addresses, but it just takes a single line to create the thing that's very commonly needed when you work with AWS, and those are the things that I always struggle with on CloudFormation. But it takes just this much of time to do all of these things. So very cool, very useful. I'm a big fan of this, and this is one of the things that sold me initially too deep into them, but it's very important that we talk about them. That because they're very important as part of our ecosystem, and that is Terraform, right? Terraform is a great tool by HashiCorp. Terraform basically is Terraform was my love before CDK came along, because again, CloudFormation syntax is something I don't like, and Terraform syntax is just amazing. Terraform uses something called the HCL, or the HashiCorp language. It looks like JSON, but it's not. It's actually quite better. Terraform has this way of working with multiple files in a single directory and making this big thing called a template, and it has like planning stages and applying stages. So it's really good. Again, this is not going to be a specific discussion about Terraform, but Terraform has such great features. It does things so much smoother than other things because it actually does it all by itself. It generates all the API calls, it generates all the other things on it. So really cool tool, really interesting. I do have a slight gripe with it when it comes to maintaining state, because Terraform needs to maintain the state of your configuration or your infrastructure somewhere, and you usually need to set it up somewhere remotely. So it can be a bit of a complicated thing to do, but it is very cool. And now it's even better. So for all of those Terraform fans out there, all of a sudden, HashiCorp and Terraform love CDK. There's actually I think it's a preview build of CDK that supports Terraform. So now, if you ever wanted to write Terraform, but again, you can do it better with a programming language, you can now actually use TypeScript or Python to develop Terraform code through the Cloud Development Kit. So in essence, you can use the Cloud Development Kit to actually deploy things outside of AWS. You can deploy things to Azure or GCP through Terraform. So pretty cool. And to get started with this, it's basically just a single node module that can create all of these wonderful things for you, right? You can just basically, this is how your new Terraform would look like in some TypeScript. So pretty cool. It has a different syntax than CloudFormation approaches, of course, but it is still a very cool way to do Terraform. So I had pretty much fun doing this thing. So pretty cool. Now, the slides you've been all waiting for, or the best practices. And this is something that I picked up from my experience of working with infrastructure as code, and also by talking to a lot of people who do this for a long time. So this is kind of my attempt to collect the wisdom of the world when it comes to infrastructure as code and how to get started with it or how to use it properly. Number one, layer your applications. Do not put all of your eggs in one basket. Make sure to divide your stacks. Have a specific stack for infrastructure, for security and identification. Have a backend stack, a front-end stack. Separate your persistent storage. Do those things. It makes it easier for development, absolutely, but it also makes it easier if something goes wrong, because you don't want your big old stack that contains all the things to go bad, and then all the things go bad and you have to have a potential downtime, right? As one frustrated user on Twitter told me, for the love of everything you hold dear, do not put your persistent storage with your everything else, because you do not wish to remove your persistent storage when you decide to all of a sudden remove your Lambda functions. Move it somewhere else. Start small and don't try to boil the ocean. Do not go ahead and try to cram everything you have into a template. Yes, you should start early, but do not go ahead and try to make everything and get stuck on a single thing and spend days and months of trying to figure out that single thing. It's fine if it doesn't work from the get-go. Put the things that work in and build your way up top. So there's so much things you can do with infrastructure as code, but take it one step at a time. And it's perfectly fine to repeat yourself. Again, even though this code is a piece of code, it's fine that you can repeat yourself. You don't have to go ahead and write a specific library to not have to type something twice, right? So it's okay, and that keeps you from over-engineering things, because you have to understand this thing has to be maintained. It's very cool. We're all engineers, and we all like to over-engineer things because, hey, it's awesome. But you have to be careful on doing that, because somebody, operations, needs to maintain this in the long run. So you don't want to get the wrath of operations on your head after the fact, right? So and here are a bunch of quotes from people who I know and who have experienced all of these things. So yeah, it's very important not to keep it simple as possible, but have the ability to improve it as you go along, because you don't want spaghetti code in your production, especially when it comes to infrastructure, as it is a critical part of everything you do. Okay, a very important part. I'm not sure why I have to keep on repeating this, but apparently I do. Use parameters and mappings. That's pretty straightforward. Use parameters for your templates. Make your templates as agnostic as possible, or have them the ability to be used in multiple different types of environments, right? You can use the same template in production and staging and development. But do not hard code sensitive information into your templates, because there's better ways to do it. There's a lot of people who put passwords or keys or something in their templates just because, oh, it's going to sit in my Git repository. Don't do that. There's better ways to do it. There's secrets managers, there's parameter stores, there's HashiCorp Vault. There's a whole different things you can use to actually store secrets and parameters instead of putting them in your templates. Again, don't do things. Even if, for example, if you would put your secret keys in a public Git repository, you would get an email from us, because we actually detect when people put in secret keys and access keys into GitHub and notify you about it. So make sure not to do those things. And last, best practices. Test. It's very important that you test your code before you put it to production, because this is code after all. We need to bring in test-driven development, or the practices around test-driven development, because you can screw things up at scale when using automation, right? So automation is very powerful, saves us a lot of time, gives us a lot of time to learn new things, and it makes us feel good, right? But also it enables us to mess up at scale, right? As you can build on scale, you can actually mess up on scale. So be really paranoid about the things you do. Have other people look at your code, have tests in place, have guidelines in place. You want to make sure that those things are safe when you deploy stuff. Okay, couple takeaways. Get into infrastructure as code early, right? Do it as early as possible. Even if you have a single instance, a single auto-scaling group, a couple of Lambda functions, do it early. You should never click. You should always write your infrastructure through code, because it will help you expand as you go along much better than right now, right? So then when it's manually. And that same code, treat your infrastructure code as any other code. Take it to a pipeline, put it in a Git repository, version control it, peer review it. All of those best practices and tools should be part of your infrastructure code, because in 2020, especially when it comes to serverless applications, your infrastructure code is, or actually your infrastructure is very much part of your application more than ever. So if you're using things such as Cognito pools or even DynamoDB tables, those things are part of infrastructure, but they're very strongly part of your application per se. And finally, use the tools that best fit your needs. Again, there's so many tools out there that exist, and usually I get a question, hey Darko, should I use tool A or tool B? Yes, you should. Because the answer here is, like, I've heard this from somebody on Twitter, the best programming language is the one you know. So this is the same thing here. The best framework, the best tool is the one you maybe know, but if you don't know, is the one that does the best job for you, right? Again, if you're doing serverless, maybe SAM or serverless framework is better. If you're doing just general architecture, if you know Python, maybe CDK is better. If you don't know Python, maybe try Terraform or CloudFormation. So again, doesn't matter which tool you're using. There's no such thing as tool competition in here, right? Any tool is great. So just use the best one that out there is that fits your needs. And yeah, thank you very much. I really hope you enjoyed this presentation. I had a fun time delivering it. Actually, let's check back on our Thursday. Oh, it's created. So we have a CloudFormation stack now provisioned. We have a VPC created. Excellent. It's been fun for me to deliver this talk. I've delivered this talk a few times before, and it's always fun for me to talk about infrastructure code because I'm very passionate about it. I hope you enjoyed it. And also, any feedback, any comments, please feel free to forward them my way through the means of social media. And yeah, thank you, Michelle, and everybody else for having me here. I hope I get a chance to do it again.